Welcome to Season 2, Episode 7 of Tech Talk Thursday. My guest this week is Mike Fredrickson from a company called Insituware LLC. Insituware produced a unique handheld device to characterize solder paste in real time before you start the printing process. The company is now launching its second materials verification module, this time to characterize conformal coatings. That's our topic this week. It's time to meet our guest, Mike Fredrickson. So I'm excited to hear you've got your conformal coating module about to launch.
Yeah, we're going to start demoing that in about 2 weeks. So we got some really cool data coming from that.
Tell us a little bit about it and how it works.
Okay. So when you look at conformal coating, the feedback that we're getting is people are interested in, is this the same conformal coating material? And the way most people view that is viscosity. Other folks are interested in cure state. In fact, we got that from the automotive community. They're very much into measuring cure state. And then thickness, which is traditionally what people have been interested in, is measuring the geometric factors post-cure of the thickness, both wet and dry. So what we're rolling out is we'll roll out each one of those over time. But our first one is basically the ability to be able to tell you whether this is the same material. We can predict viscosity. And we can do that very rapidly. And we can do that in situ. We can do that very quickly. We can actually adapt to changes in temperature. And we can actually give you, we can give you percent solids. We can tell you how much the solvent is also evaporating.
Okay, but you're not doing anything connected to the composition of the coating.
Not the composition, only from the perspective of percent solids and its basic viscosity. That's basically what we're going after. So we're using a technique that's been around for many years in the composite world and in the polymer world. We're using a very similar technique. It's just we're using multiple sensors. We actually are keeping track of temperature. We're keeping track of a lot of different factors within the material to be able to predict viscosity and predict percent solids.
Right. Okay. So it's going to be more of interest to people that are really interested in determining the thickness coding for LED lighting applications, that type of thing.
So what drives thickness is the base material. So if your application is consistent, so in other words, if your machine is consistent in its ability to consistently apply the material, then the one thing that's if you control the material and you control the process, you control the thickness. So we're going to have a capability in probably Q2 of 21 to be able to look at thickness. We actually have that working in our lab, but this actually fits more into our vision of if you control the materials and then you control the process, you'll control the thickness.
Okay. So looking at, does it work with all different types of coatings? Does it work with acrylics, with epoxies, and silicons? Doesn't matter what type of coating it is?
Correct. We have to adapt for that. So the one thing that we're doing that makes us a little bit unique is that's exactly similar to what we did with solder paste. We will adapt our measurement based on the source material. And then that's where we use our machine learning methods. We use our data analytic methods. We use our multi-sensor, keeping track of environmental information. We use that other data to give us more accurate results across the epoxies, the acrylics, the silicones, and probably the one material we're not going to measure is the parallenes. It's probably just because of the process is so different. Right.
Okay. So the measuring process is similar to your Vision Mark 1. You smear the material over a comb, which then measures it. Is that how you do it?
Actually, what you do is it's actually it's very much a very the neat thing about conformal coating and solder paste is it actually uses the same Insight module. So once you buy the unit for solder paste, this comes with just the purchase of a probe. So that's the nice. The probe is very different. It's extremely different. What you do is you actually put the probe in the if it's a coating machine, you actually spray the material into a cup, basically, and you fill it to a certain level, and then it makes the measurement.
Okay.
So it's that simple. So if it's automatic spray coating, and it'll actually be on a board that you can just send through the unit. It'll go in there, you fill the cup to a certain level, and then it'll give you a result in, I don't have the exact timing down, but it's within a minute or so. It'll tell you whether that's the same, what the viscosity of the material is, predictive viscosity, percent solids. It'll give you that information.
But is the intelligence still in the cloud here, or is this intelligence that's actually in the handheld unit?
So it's good you mentioned that. Based on feedback over the last 6 months, we've had a lot of feedback that people wanted in the handheld unit. So the production units that will start rolling out in mid to late November, and then we'll have our full complement of production units by the end of the year. It's all in the handheld unit, so you don't have to be connected to the cloud. To get the SBC data, you need to be connected to the cloud for obvious reasons with the data. But yes, the handheld unit will have the smarts in it. That's a change that we made.
So basically, this is not measuring coverage at all or anything like that. That's done by all the vision inspection systems that are already out there. Yeah.
We're trying to get ahead of that. It's no different than SPI for solder paste.
Right.
You can measure it after you print, or you can measure it before you print.
So, all right, just try and avoid making the problem in the first place.
Philosophy: if I control the materials and I control the process, I should be able to control my quality, right? I should be able to control my whatever the quality standard is that I'm looking for. I should be able to control that if I can control materials and process. And we know that the coating machines are really intelligent today, very intelligent. In fact, some of the having looked at a lot of the newer systems and some of the new technologies, they actually heat the solder paste. They actually heat the conformal coating material. They actually raise the temperature of it to adjust its viscosity, so that they can spray it. So that tells you that temperature and viscosity are very, very related. The difference with that, though, is that there would be obviously a different percent solids. So that may adjust the viscosity, but you're putting down polymeric particles, the solids that are in the material, whether it be evaporative like an acrylic or whether it be cross-linked like an epoxy. That's going to control the end result. So our perspective is you control the material, you adjust the material as needed, and then the machines that are out today are consistent enough that you should get very, very consistent coating results.
Try first. Don't just say, I can't. Try and find a way to do it.
We will exceed your expectations.
Nice to meet you. We are Omron.
So are you measuring the coating before it goes into the dispenser or after it started spraying it?
So we're measuring it because most of the coating material, so there's two applications. Most of the coating material is in a pressurized container in machines. And so because of that, it doesn't give us ready access to have that instrumented there. So really what one would be concerned about would be what is the material after it goes through the whole spraying unit, after it goes through the entire event, all the way from the pressurized unit through the system through. And so that's why we fundamentally believe that you should measure it as it's coming out of the machine, because that's what you're actually putting on the assembly. And
I mean, don't you set the viscosity on the machine, and it applies sufficient heat to be able to spray it at that viscosity?
That would be correct. However, that's not the same material, right? So if you're heating, if you think about, am I putting the same material on? If I have to heat the material to get the viscosity to change, then I'm altering the material to achieve the viscosity, which is great from a spraying perspective, but it's not necessarily great from the end result. Did I put the same amount of polymeric solids? Did I put the same material? If I heat that material to change its viscosity, did I put the same material on that board that I put on the other day where I didn't have to heat it? It's a different material.
I understand that. So basically, what you're saying is that the designer or the EMS company is buying this material at a certain specification with a certain amount of solids in it, but by the time they spray it, if it's had heat applied to it, it has a different characteristic, and your machine is quantifying and verifying what the solid content is.
Yes, exactly. Percent solids. That's what we're looking at.
Right.
Exactly. Right. So we can predict based on knowing the temperature and the percent solids. We can predict viscosity, but you're right. The machine is adjusting that in order so they can improve the spray. So you look at two factors. One is percent solids, and the other is effective viscosity. So if it's a handheld unit, we've talked to folks that are using that and they're interested in that. If it's a really advanced spray coating unit, then you're right. Then we would principally be looking at percent solids instead of viscosity, because they're controlling the viscosity with the temperature, which is why we need to know what the temperature is. And so why we actually measure that. We actually keep track of that very carefully.
Is there a market, an OEM market for this product, as well as a end user market?
So from an OEM perspective, it would be the feedback that we're getting is people trying to make sure that they're putting the same coating material down that they'd put down before. So I visited one OEM, and they said from time to time they'll go through the exact same process, put the exact same material in, thin it the way they think it's supposed to be thinned, and then they'll spray coat it, and it takes, in some cases, it takes sufficiently longer to cure, and they actually have because in a lot of cases they're actually shipping the units actually in a partially cured state. So they go through the oven, they go through the cure oven, and then they ship it. So they're actually being shipped in a partially cured state. If it's in a different partially cured state than what they had intended, there can be some, and they've had some returns because of that, because the material they laid down was different than what they had laid down before. All the processes were the same, the curing processes were the same, but the material was different. So its cure process was different.
So are you testing it then post-spraying or post-curing?
We're actually doing both. So the first unit that's coming out by the end of the year, we're actually measuring percent solids. And then in Q1 of 21, we'll actually have a cure state monitor. So we'll be able to measure cure state also. So those are kind of our two priorities, which is if I can measure the material itself and get a percent solids / viscosity, depending on how you're using it, and I can also measure cure, then that's kind of our order of priorities. Is it the same material that I put down before? Or if you're in the high rel market, is this the same conformal coating I qualified for my product in automotive, aviation, military? Is this the same material I qualified? Right. So that's step one. Step two is what's the cure state at post oven or after a certain length of time, and that's where we've been getting a lot of feedback from the automotive community. Is that is incredibly important to them, is knowing that cure state, and so being able to monitor that, and then lastly, we'll actually have a system that measures the thickness. But by the time you're measuring the thickness, something else went wrong with the materials or something else went wrong in the process, right? So that's kind of our order of priority, which is if we can get at the material, we can get at the cure process, then our last is because of the demand, people are looking for a handheld unit that will actually, with the whole family of modules, people are looking for something that they can actually have present in a conformal coating room. So what people are asking us is, the AOI systems have a lot of this capability, but they actually want something they can put in a pretty rugged environment in a coating room, and that's so they can double check the thickness. Right. So,
right. Good, interesting. the system you've got at the moment with the Vision Mark 1 for solder paste measurement, I mean, is I believe a subscription-driven business model.
So yes, we started with the subscription. We actually, when we first got started, everything was a subscription where we're actually giving you benchmark data on the material. So if you're using a particular solder paste or you're using a particular conformal coating, you're going to be able to see how you're using this material in concert with the rest of the industry. What we moved to, again, by user feedback during this time period where we have a number of people using this device, we've gotten feedback that what they wanted was a basic subscription where they could use it for SPC, and then an enhanced subscription where they could do the global benchmarking, the alerts, and things of that nature. So right now, we're not charging for that. If you buy the unit, you get the basic subscription at no cost for the life of the product. And then if you want to subscribe to that, then you can. In the first 100 units sold, we're actually giving away the advanced subscription for the first year. So people kind of get a handle of what we're actually able to provide. And from my experience, it's interesting. We spend tens of thousands of dollars monitoring components and monitoring everything from obsolescence to counterfeit. We spend a lot of money actually tracking this, but we don't spend any money tracking our materials, the raw materials. We don't.
It's very true. It's very true. But I mean, if you've given out, as you said, 100 licenses there, presumably you're getting a lot of data coming back.
We are.
Are you able to quantify any quality improvements, in yield improvements, and these types of things coming out of that data?
So clarification, we have about 50 units that are out right now that are being used in various locations for short periods of time. The 100 units I was talking about was the first production run of the systems that people will be using in the first 100, and that's where we're giving away the advanced subscription. One of the interesting things that we're finding, which we started this with controlling your materials to avoid defects. And that was kind of our whole mantra of avoiding a defect will save you money. Well, interestingly, 2 or 3 manufacturers that are using this, we actually got a phone call and they're like, I'm able to extend, one manufacturer actually extended their solder paste by days. The quality department kind of shut them down a little bit on that. But other manufacturers are finding that they can get an extra hour to 2 hours out of their paste. So if they had, say, a stencil life of 6 hours, now they have a stencil life of 8 hours. And the reason is because they're more confident. So most manufacturers, based on the information they're getting from their SPI, will be conservative because a defect actually is more costly than changing out the solder paste. But if you can keep track of what's going on with the solder paste, you can extend the stencil life another 2 hours, an hour to 2 hours. And if you do that math, then in a reasonable volume of a manufacturer, you're talking thousands of dollars. We did a quick assessment with a couple of manufacturers, and the payback for this unit, for the unit just measuring that, is about a week and a half to 2 weeks if you can extend another hour to 2 hours.
Wow.
Just on cost of throughput.
But this is it. I mean, I think this is, where manufacturers are going to see the ROI when you start being able to produce that quantitative data on as you said in this case, how much time they can save or keep the paste going on the stencil. It's really going to help. Okay, we've covered quite a bit of ground already, and I just realized that we've been recording. I didn't think we were. I thought I was just doing the preamble here. So I don't know. Is there anything in what we've discussed so far that you're not comfortable with?
No, I kind of hesitate. If you're going to do some cuts in editing, I hesitated a couple of times, but
worry too much.
But no, I think I pretty much covered it. I think the funny part was, in fact, I called Megan, and to her it wasn't a big surprise, but to me it was. I was so excited when these manufacturers are like, forget the defects. I mean, we're saving money just on extending the material life. And I think that's going to be true with conformal coating. I think that's going to be true because people get nervous when it comes to materials because they just don't know. They don't have the knowledge, and they just get nervous. So conscientious manufacturers will back up and put rules in place, which I remember as when I was on a factory floor, we operated by rules because we just didn't know. But we knew, okay, if it's raining, then we can get 4 hours out of the stencil if I'm in, a stencil life. And if it's not raining with this particular, I can get 6 hours. I mean, that's what we did. And I think the fascinating part is that having this knowledge now allows people to just make good, smart process decisions like we made with, our reflow ovens or cleaners. And, we knew that if we set up a specific spray, pressure and all these things in the cleaner, we knew we could get a particular result. But we always had to make the assumption that the saponifier was the same. And so it's that interesting knowledge base now that we're providing that is now enabling people to stretch out a little bit and still produce quality products by actually getting the full service life now out of the materials, which is really exciting.
So, correct me if I'm wrong, but I mean the latest versions of the Mark One include a humidity sensor and temperature sensor.
Yep.
Yeah. So does that make any difference also to the conformal coating and how it performs?
It does. In fact, the sensor itself has sensors on it because conformal coating, solder paste is very sensitive to humidity, not so much temperature. Conformal coating is very sensitive to temperature, as you can imagine, because of the way that they treat it in thinning it with heat. So yes, it does. And in fact, in the case that it is so sensitive, we actually incorporate a way of measuring the temperature embedded in the actual probe itself. So we're not, when we actually develop a new technique to monitor and measure a material, we don't have any pet technology that we're pushing. We actually do a very broad brush of current known methods of controlling this material. We look way deep into public domain, published articles of similar materials, and we look at a variety of different technologies, and then we neck them down. And in some cases, we use multiple sensors to get at it. And we're not married to any sensor. We're married to the sensor that works and gives us the most accurate data and gives us really good gauge R&R so a manufacturer can actually use it.
It's a fascinating subject area, Mike. It really is. And I think it's a great thing that you're doing with this, materials measurement system that you've got. But I want to wish you the very best of luck, of course, with the conformal coating system, which is going to be available when?
It's going to be available at the end of the year. So actually, when we're rolling out the volume production units, it'll actually be available. And it's
great. Okay. Well, we'll look forward to seeing or hearing back from you once you've got some units in the field. But for now, I want to thank you for joining us today.
All right. Thank you so much.
Global SMT and Packaging opens the windows of the world to bring you the latest news and technologies from Munich, from Bangalore, from Shanghai, from San Diego.